everyone, my name is Santosh Kumar. Today I am presenting the Capstone project on financial forecasting frontier with distributed machine learning. So this is the Capstone project on banking data analytics with Hadoop, Hive, Apache Spark, Spark ML and Spark streaming. The introduction of that banks generate enormous volumes of customer transaction and campaign data every day, and the value of the data depends entirely on how quickly and reliably it can be turned into the decisions. This project builds a complete distributed data pipeline for the bank marketing dataset, that is bank.csv, covering the full journey. A real banking analytics team would follow, storing data at scale, exploring it, predicting customer behavior, monitoring transactions as they arrive, and understanding how the underlying distributed engine parallelizes their work. The dataset used here comes from a Portuguese bank direct marketing telemarketing campaign for the term deposits and contains 4,521 customers across 17 fields. On that demographic attributes: age, job, marital status, education. Financial attributes are accounts balance, existing loans, and campaign contact details, call duration, number of contacts, previous outcome. The target field Y records whether the customer subscribed to a term deposit. Rather than analyzing this data with single machine tool, the project deliberately uses a distributed computing stack. Hadoop, ITFS, the distributed file system bank used to store data too large for one machine. Hive, a SQL layer over distributed storage simulated here via Spark's SQL catalog, so that dataset can be queried like a data warehouse table. Apache Spark, the distributed engine that performs exploratory analysis, transformation, and aggregation in parallel across partitions. Spark ML, Spark distributed machine learning library used to train model that predict which customers are likely to subscribe. Spark streaming, structured streaming, that is used to simulate and process a live feed of banking transaction, the same machine mechanism a bank would use for real-time fraud detection and monitoring. This notebook is built to run top to bottom in Google Colab with zero manual setup. Besides uploading bank.csv prompted, every cell below has been checked to run clearly, and every chart is generated live for the data. Nothing is static screenshot. So the five sections of follow map directly to the five capstone objective. data storage and management, exploratory data analysis, predictive modeling, real-time transaction analysis, and data parallelism. So we have imported the matplotlib pyplot at plot plt. After importing, we have made the figure axis on that, set that axis, and range node for I in range length node x, and axis plot graphs. After that we have scatter that, and so we have made the cover image. We have installed, after that install PySpark, pip installed PySpark. So we have installed the PySpark. Then environment setup. We have initialized a local Spark session, local asterisk, uses the shell CPU cores available in the Colab VM to parallelize work, which is exactly the mechanism for real multi-node cluster usage across machines instead of cores. From PySpark.sql import Spark session. From PySpark.sql import functions as f. We have import structure type, structure field, integer type, and string type. So this is the Spark version of 3.5.1. Default parallelism is 2. Loading the banking dataset. We have load the banking dataset, and it have the structure field age, job, marital, and then education, default balance, housing, loan, contact, day, month, duration, campaign, etc. So this age is integer value, and job is string value, marital is string also, education is string, default for string, balance is integer, housing is string, loan is string, contact is string, day is integer. So we have made that a table for that: age, job, marital, education primary, secondary, tertiary, and secondary, etc. So total records are 4521, and total columns are 17. We have 1 minute. So this is the 17 column. So this is the real time data. On that we have uploaded the CSV file. So the objective is data storage and management with Hadoop plus Hive. Persisted dataset in the distributed format, the formatability of ADFS, and the register in the Spark SQL catalog as managed table, so it can be queried with SQL exactly as the analytics team would query a bank's data warehouse with Hive. So this is the warehouse path. Spark.sql, we have query for that. Select job, round average balance as average balance, count strict as customers. From banking, customers group by job, order by average balance, DSC dot so. So Spark SQL made for that. So it has data posted with the content bank paraquet in the paraquet format, ITFS. So default have no value. Balance that many different balance, housing and loan. This is showing job. So we have run the code and this is the output of that. Second objective is exploratory data analysis with Spark. Data quality check. Confirm that there are no missing values in, then review summary static for the numeric field. We have df.select with app count, df.describe age, balance, duration, campaign, period and previous. So this is the age, job, marital, education, default, balance, which have these values. In summary, age, balance, duration and so on. Campaign, period, previous. So this is the life. And then the target variable distribution. Target y variable distribution. Target y term deposit description is imbalanced. This matters for how the model is evaluated later. So this is the term deposit subscription. So more people have the no term deposit subscription. This is the value is 4000 and rather than 521 have the term deposit subscription with yes. So this is the bar chart. After that the code run. We have made the subscription rate by job and education. Which customer segments respond best to the marketing campaign? So we have run the code and the output value is these. Term deposit subscription rate by job. So job total subscribed and subscription rate packet. So term deposit subscription rate by job. This is retired or more people than student and unknown, after that management, housemaid, admin. So total term deposit subscription rate by job is more than is retired people. These are more than 20 and the subscription rate per hour. Territory have the 14.3, secondary have secondary education have 10.62, unknown have 10.16, primary have 9.44. Subscription rate packet, this is the value for that. So the call duration balance correlation with subscription. Longer calls strongly associate with a yes outcome. We also check Pearson correlation for the between each numeric field and the subscription outcome. We have made this a program on for that, and plot a graph by the code correlation of numeric feature with subscription. So this is the duration by duration are and campaign, and they have the x value, and correlation for numeric features with subscription have y value. This is the largest duration for 0.4. Then subscription rate by the previous outcome, loans, marital status, and contact type. So we have uh, made a code for that. For column in, we have made the code, and this is the value for that. This is the three values: subscription subscription rate for outcome, P for outcome, and subscription rate by housing, and subscription rate by loan. Loan have two values. Subscription rate by marital have three values. Subscription rate by contact have three values. With the telephone, total have 301, and cellular have 2896, and unknown have 1020, sorry, 34, 1 1324 have the total value by contact. Subscription rate by packet are: telephone have 4.62, 14.62, and cellular have 14.36, unknown have 4.61. Objective 3: predictive modeling, Spark ML, feature engineering pipeline. So categorical columns are indexed and one hot encoded. All features are assembled into a single vector column as required by Spark ML estimator. So this is the code for that, and we have the print the training rows, train df.count, and testing rows, test df.count. So training rows are 3662, testing rows are 859. Train and evaluate models, we have made a code for that. So model compression, logistic regression, and versus random forest. So this is the important value for that. Logistic regression have the blue value, and random forest have the orange value. AUC, accuracy, F1 point, precision, and recall. So after that, feature importance for that, inspect with the engineered features, the random forest relied on the most. This is the feature index, and this is the importance for that. These are the value. Feature index maps positionally to the one hot encoded plus numeric columns in the assembler inputs in that order. So random forest feature importance are: for 47 age is the maximum. 43 have the 0.10 impotence and 26 have the lowest value. So this is the feature index assembler inputs. This is the objective for real time transaction analytics. Spark streaming. A structured streaming query watches a directory for new transaction files and flags high risk transaction in the real time, mirroring how the bank would monitor a live transaction feed for fraud or unusual activity. So we had made for stream input directory, contact content stream input, stream checkpoint directory. This is the code for that. So streaming query started is active. It have so we have simulated live feed for banking transaction by dripping small batches. We have made the source of pd.read csv data path. Chunk size is 500 numbers. After that we have made this, and after batch 1, after batch 2, after batch 3, count the batches. So live risk monitoring flagged transaction per batch. So high risk is shown with red values and normal is green values. So we have shown the streaming batch with the transaction count. So normal is showing more values and streaming batch is lowest values. High risk is lowest part with red. Window operation and water making out of order data. So this is the code for that, and we control synthetic event time, and this is the code after run the point. So it shows the water marking check, and we have made the trend curve, transaction count and average balance over time. So this is the transaction curve. It have the transaction count and average balance. Average balance is showing with orange values and transaction count is blue values. After we have made the partition at each stage of data paralleling. So this is showing the partition. So the conclusion and learnings. This notebook implemented our five objectives that the capstone against the real bank.csv dataset, storage management, EDA with Spark, predictive modeling, real-time streaming, and data paralleling. So this is the practical value. Data path and warehouse path and the streaming source need to change, making realistic template for the production banking analytics. So future improvement are class imbalance handling, class weighting or smooth. Hypermeter tuning via cross validator, a genuine Kafka streaming source and deployment managed cluster, Databricks EMR no, or frame YARN for elastic scaling. So thanks for watching. This is the project on financial forecasting frontier with distributed machine learning.